Hello, everyone. Good afternoon. Thank you guys all for coming out to the session. I hope you guys are excited for the first day of EuroPython and for this talk as well. So it seems like there's a lot of you in this crowd. Out of curiosity, who here is building an AI app or an agent? Okay, there's a good mix. So for those of you who already have some experience building agents, hopefully I'll show you some tools today that's going to make your workflow faster. And for those of you who are just starting out, hopefully I will show you some things to help you get started. So for today, what we're going to build together is a simple weather agent. And that agent is going to be connected to tools that allows us to ask questions that rely on real-time data. So that means we're going to be able to ask this agent questions like, what's the weather like today in Prague? Or even more advanced questions like, I'm in Prague for a few days. Can you recommend me an itinerary that matches with the weather conditions? So before we get into the building part, let's do a little bit of level setting, because we all might have a slightly different definition of what an agent is. So at a very high level, an agent is a system that can take a user request, it can reason over it, and then come back with either an answer or it can take an action on behalf of that user. And so if we have just a model by itself, it only has knowledge that it was previously trained on. So in order to supplement that knowledge, we have to give the model access to tools. And these tools can be things like access to APIs or databases or web search. And by supplementing the model with these tools, you can make it a much, much more powerful application. And that's where the agentic part comes in. And the MCP protocol, which stands for, or the MCP, which stands for the Model Context Protocol, these tools are hosted on MCP servers, and that's what allows it to be plugged and played into the agent system. So for this talk today, we're going to start completely from scratch, and we're going to build an AI agent locally in VS Code. So that's going to be done through an extension called the AI Toolkit, which you might have seen some videos for playing around the conference. Then we're going to take that agent that we've built, turn it into a web app using GitHub Copilot to make it into a full-fledged deployable app. And so once that local part is done, we're then going to take it to the cloud, deploy our web app to Azure Container Apps, and as a bonus, I'll also show how you can deploy a model as well as the agent itself to Azure AI Foundry. Okay, all right, back in VS Code now. So, as you can see here, we are starting with a completely empty repository, and we're going to use an extension called the AI Toolkit to help us build our agent. And as this is loading, I'll go over some of the components. So the AI Toolkit has a bunch of tools to help you with AI development, like a model playground, an agent builder, and evaluations, which we're going to go over. So the first thing that we need is to find ourselves a model for our agent. So heading over to the model catalog, there is a huge list of models that are supported by the AI Toolkit. Some of the popular ones include DeepSeek, 5.4, and OpenAI's GPT models. You can choose any models that are hosted on GitHub, and these are a great option to get started with because they're completely free. And you also don't need an API key to get started. You only need to log into your GitHub account. Other alternatives include Azure AI Foundry, as well as Onyx or Ollama. If you have those installed on your machine, you can run models locally. And lastly, of course, if you want to connect to a third-party provider directly, you can do so if you have an API key. And examples there include Anthropic, Google, and OpenAI. So adding a model is super easy. I'm going to go with the easiest option, which is adding a GitHub model. And once that's added, it will show up on the section on the left here. I have two added, and to play with it is very simple. You just simply click Try in Playground, and it takes you to a pretty standard but robust playground. So on the right-hand side is a system prompt where you can enter in instructions to guide how your agent responds to users. It also has access to tools like attaching in a file or web search. But for our case today, I'm just going to go ahead and say to it, hey, I'm in Prague. What's the weather like? And that's going to come back with a response. It's also going to calculate the token count, which helps you get an understanding of how much resources the model uses. And if you'd like to compare resources across models, you can use this option and select any of the other models, and that will compare it side by side. So it looks like the response we got back from the model, as expected, it cannot get the real-time weather data. So that takes us to the next step, which is building our agent in the agent builder. So in the agent builder, we have a couple of different sections. So first is the model, which we have previously decided was going to be GPT-4o because it's pretty good in terms of both cost and capability. The next section we have is the system prompt, where we're going to provide the instructions to the LLM. And then let me just clear out stuff from my previous one so I can go through it from scratch. And so in the system prompt, I'm going to give it some instructions, such as you are a weather agent, and you are going to help the user get dressed. Check the city they're in and give recommendations on an outfit or accessories. So this really makes sure that our agent is able to provide the level of detail that we wanted to respond with. And then for the user prompt, I'm going to say again, what's the weather in Prague? And this time, I'm going to connect our agent to tools. And you can do that either through a custom tool or an MCP server. So I have here loaded a server that is connected to weather data, and that has access to two tools. One is a get daily forecast tool, and then the other is a get hourly forecast tool. And I'm going to add that to my agent so that it can now have access to these tools. So the system prompt is going to determine which of these tools are necessary, and if a tool is necessary, to be called in order to be incorporated into the result. So I'll give that a run. And on the right-hand side, you can see what the agent is bringing back to us. So first, it selected the get hourly tool. We also see the tool response. So we have data on the hourly breakdown of both the temperature as well as a description of the weather. And then the model response comes back, and we can see that it has summarized the live information from the weather MCP server and responded to the user with recommendations. So let's see together if we can actually make this response any better. So for one, I think this response is kind of long. And then two, I want to specify exactly which tools are called. So in my system prompt, I'm going to say, if the user doesn't specify the date, use the get hourly tool and tell them what time of day it is in the recommendation. And then if not, use the get daily tool and then summarize in 2 to 3 sentences so we get a shorter answer. Okay, so now we have control over our tool call. We have explicitly told the model we wanted to use it under these conditions, and we have a much shorter response that is both time relevant and specific. So up until now, I have been testing with just this one single city. If I want to change this into a more robust testing data set, I can actually change this to a variable using this syntax. And you can either fill in the city here, or if you want to run this against multiple iterations, you can actually head on over to the evaluations tab. And here, by defining this variable city, we can create a data set that has different versions of our user prompt to make sure that the response that we're getting back from the model is as expected. And I wanted to point out a feature here, which is an AI-powered data set generation. And this generates logic to add rows to our data set. And the great thing about this feature is that it can identify based on what you've named it, so it's contextually aware, And it also not only generates variations of the positive test case, but also the negative test case. So if you scroll down, you'll see these are all valid cities, but soon we get to cities like Atlantis, which is fictional, as well as bad data. So you can see how the model responds to a variety of different test cases. And so for each of these rows in your data set, you can go through each of them manually and read through the responses, but that is a pretty tedious process. So instead, what you can do is add evaluation metrics. And so in this toolkit, you have access to a number of standard metrics, for example, relevance or coherence. And if you add these to your data set and you run your evaluations, that will generate a metric, it will calculate a metric for each of the rows in your data set. So at a glance, you'll be able to see a sort of numerical score on how good your agent is performing. So now we have an agent that we're happy with, and as developers here, we are probably wondering, where's the code? So that is where this option comes in. So clicking View Code gives you access to all of the code that comprises this agent. So we can choose between any of these SDKs. And then this generates the script for our agent. I'm going to go back to my user prompt and change city back to Prague so we can run the script and just test it out. And let me just give that a run. And as that script is running, it's going to call the MCP server, give us responses back, which we'll see in the terminal, and also output the model response. So there we have it. Okay, so that concludes the first part of this, which is building the agent. So the next thing that I said we were going to do was turn this into a web app with a chat interface. And the catch here is that I'm a Python developer, so I don't have much front-end expertise, so I'm going to use GitHub Copilot. And what I'm telling in my GitHub Copilot prompt is that I want to turn this Python app into a backend hosted on a Flask server. And I also wanted to generate a front end using JavaScript, HTML, and CSS. And then I also give it some details about what kind of user interactions they can take in the code. For example, adding an option to clear history, being able to chat back and forth, and seeing the status of the message. And then I also gave it some styling details about like colors and construction. So that takes a while to go, but it will, as you can see, it will modify the current Python file. And then as it's working, it will also generate those JavaScript, HTML, CSS files, even though they previously did not exist. And so if that all goes well, we get taken to something like this. Okay, this code space isn't loading, so I'm going to switch over to a different one. Or actually, let me try this again. There is a big reveal after this. Okay. Since it looks like it's taking some time, in the meantime, I'm going to jump around a little bit. So I'll show you the app after. In the meantime, I'll show you how you can load a model and an agent into AI Foundry. So up until now, we were using the GPT-4o model hosted on GitHub, but that has rate limits. So if you want to take your app to production, it's better to have it hosted on AI Foundry. And that can be done through the AI Foundry extension plus the AI Toolkit extension. So if you have the AI Foundry extension loaded, you can go to the playground, you'll see, the catalog, you'll see AI Foundry in the list of model options, and deploying it is really as simple as 2 clicks. So 1 click to click deploy, and then the second click is for validating that the settings on that model are what you want, and then that will simply deploy your model to Foundry. And after that deployment is done, your models will show up on the left over here. And then the next thing that we want to do is deploy an agent. And so let's head over back to the AI Toolkit Agent Builder and select the 4o model on Azure AI Foundry instead. And then this time, instead of seeing the other SDK options, we have 2 here. One is the Azure AI Inference SDK, which is built by Foundry, and then a semantic kernel SDK, which is also managed by Microsoft. And so here I'm going to give it, I'll give it a better specific name. And then this time, what happens is, inside of the script that was generated for the Azure AI Foundry model, there was a section to deploy the agent. And so just by running it alone, that will deploy your agent to Foundry. And so in the terminal output here, it'll tell you the status of the MCP connection. It'll also tell you the response back from the model given the user input that we provided. And it'll also deploy that to Foundry. So this time, if we check our AI Foundry agents, you'll see that we have recently just deployed a EuroPython agent. And that's really as simple as it is, like just a few clicks inside of VS Code in the extension. Okay, so it looks like this is refusing to connect. Give me 1 second to make some changes, and then I'll show you what it's supposed to look like. I do have to hide it from my screen, though. Okay, so let me change this to my 5000 port. Okay, so if the Copilot generation works, this is what it should look like. So this is the local web app that we built earlier. It's being hosted locally on my machine. And if I click this, this is the result that we get. So we have a fully fledged UI interface where we can chat, ignore my previously saved results. So we can chat with our agent now. And this was completely built off the same code that I used in the agent builder and just wrapping it with web UI code using GitHub Copilot. So now we know from the agent that it's raining outside, and we know how to dress for the conference. So for the last step, we're going to take this app and then deploy it to Azure Container Apps. And that really consists of 3 simple steps. So first, we need to initialize this with an Azure YAML file so that we have the right configurations. Second, we were installing our MCP server using npx, which means that we actually need to add a node installation onto our container. And then lastly is just the action of deploying itself. So the first step is really, really simple. It's just azd init. And that's going to scan our current repository and generate that Azure YAML file on your behalf. So that's this file here. And the second step is where we need to create a Docker file. And in this Docker file, we're going to first specify that we're going to work with a Python base image. This one actually comes with Node installed, but for good measure, we'll also add instructions to install Node.js. And then in this Docker file is also instructions to run the requirements.txt and expose it on this port. So I'll save that. And then the very last step is also just one line, which is azd up. And that will both provision your resources and deploy them. And so within a few minutes, this was going to build, it's going to deploy, and then we're going to have an app that you can share with others. So that was the provisioning step. This is the deployment step. And so I have actually deployed this once already. If you do it for the first time, it usually takes around 10 minutes or less, which is already pretty good. But if you have already deployed it, it actually only takes a matter of 1 or 2 minutes. There you have it. So this time we are seeing the deployed app. And I've given it a message, which is, hello, I'm in Prague. Is it time to party? And that's it. So we have gone from start to finish, completely from scratch, started local on VS Code with the AI Toolkit, building our agent, turning it into a web app, and then deploying both the model, the agent, as well as the web app to Azure Container Apps. And this is a fully deployed working app.
All right, Sharon, thank you for the presentation despite the challenges. We apologize for the technical hitches. We have time for one more question, just one question, and we'll wrap it up. So there's a mic behind, you can make use of it.
Hi, thank you for your presentation. So may I ask you a question? So what you show here is really nice. Is AI Toolkit support multiple provider, like cloud provider, like GCP, AWS? Or do we need to do something else to make it similar work?
It currently doesn't. So right now we only support AI Foundry and GitHub hosted models. Yeah, and then the other cloud providers are not supported.
Nice, thank you.
If people have questions, please feel free to stop by the Microsoft booth afterwards. I'll be there in the afternoon. If you want to stop by, just say hi or to ask any questions. And if you guys want to try out any of the tools that were shown today, they are here displayed on the screen, and you can scan that QR code or visit the link to go check them out. Thank you, everyone.
Thank you, Sharon.